Hi everyone, welcome to our very last video for CMPT 140, and it's going to be all about dictionaries. So if you remember back to, I believe it was the list video, I said, oh, there's these things called dictionaries that have key and value pairs that we can use to store compound data. And then I think I might have said that we won't cover it in this class. I lied. I'm going to blame it on a brain fart. I forgot we do cover some of the basics on dictionaries. We don't fully go into all of the functionality of them, but we kind of lay the foundation so that if you are going to move on to CMPT 141 or 145, you understand that they exist and how to do some of the basic operations with them. So dictionaries are simply that, a way for us to store compound data, so a whole bunch of atomic data values together. And instead of lists where we would have some sort of ordered data where we would be accessing things by position or index, we access things in dictionaries by keys. So a key would be looking up, just like in a paper dictionary, a specific word, and then the value could be something like the description of what that word actually is, or what type of word it is. Is it a noun? Is it a verb? Is it whatever, you know? And we can do those kinds of mappings for all sorts of different things. They become very, very useful in our programs. And we're going to see some examples of that in our exercises here. So the very first exercise that we're going to go through is we want a dictionary called schedule that represents an employee's work schedule where the keys are going to be the day of the week and the values will be the number of hours the employee is scheduled for that day. So we'll write the processing code that's going to create that dictionary and then assign it so the employee works 8 hours on Monday, 7.5 on Tuesday, and 8 hours on Thursday, and 7.5 on Friday. So I'll just bring up my processing right here, and I'll probably have to move it around on the screen a couple different times just so I can make sure I get all of those values correct. But creating a dictionary is very similar to how we would create a list. So pretend we were making a schedule or a list schedule. I'll just show you what that would look like. We would use those square brackets to make the list, and then we would have values inside of that. So maybe we were just keeping track this way. Who knows? Making things up as I go here, right? Where each element of the list represented how many hours that individual worked, and then maybe we had to, in our brain or in the logic in our program, map that back to days of the week somehow. Not maybe the most intuitive. But building a dictionary is very, very similar. So we can build up that schedule dictionary, and instead of using square brackets, we just use the curly brackets or curly braces. And that tells the computer, hey, this is a dictionary. Expect key value pairs instead of some sort of collection with an ordering like we would see with a list. The curly braces, you just have to press shift and then those square brace keys to get those. So same kind of spot. Now to make the key value pairs, we could leave it like this if we wanted an empty dictionary. But if we want to hard code in those key value pairs, all we need to do is start typing them out. And so we have to do these days of the week. Those are going to be strings, and so our keys in this case will be strings. And then the values are going to be, I believe it's going to be floats and integers, right? So we have a little bit of both in there. So we need to do Monday for 7.5 is the very first one. I'm going to get rid of this because it's going to be confusing because I didn't follow the same numbers. So Monday, we just go inside of our curly braces, double quotes or single quotes to start our string, type out our string and close it, followed by that colon key. So this is saying here is our first key, and then the colon inside that curly braces is saying the value associated with that key is, what was it? Oh, sorry, it's not 7, it's 8 for Monday. It's up here. I have to read the question better. Is 8. Okay. And then if we want to add more than one key value pair in, we just do a comma and then we start with our next one. So our next one here would be Tuesday. And then that one was 7.5. And we keep on going with the other ones as well. We have Thursday 8 and Friday 7.5. So Let me just make this bigger so you can see everything I'm typing here, hopefully. Thursday, 8, Friday, 7.5. And that's all of them. And just for sake of argument, to show you what this looks like when we print it to the console, we'll just run this by printing it and we'll see what it looks like down here. And is it going to yell at me about something? Didn't run. What did I do? Stop. Try running it again. Good. Oh, I thought for a second I still had this in Java and I was like, did I really forget on the very last video to change that from Java to Python? But no, we're good. So you can see it looks identical to how we would type it in if we were just printing a dictionary to the console. So we have the curly braces, the key, colon, value, and then if we have more than one key value pair, just comma separating them all. All right? Rid of that. So we did A here, where we created that schedule. But say we wanted to modify it. We see in our part B here, it's much more dramatic than what I'm saying. Oops, we have a scheduling error. So we're going to update that dictionary we have so that the employee works the Friday hours on Wednesday instead, and then remove Friday from the schedule. So we go over in the textbook how to do that, but we'll go over it together as well, just so that it's kind of reiterated here, because it's really important to know how to do these things. So the very first thing we want to do is we want to add in a new value for Wednesday that matches the current value associated with Friday's key. The reason we wouldn't delete Friday first is because we don't want to just get rid of that Friday and then we'd be like, oh, but how many hours was that person supposed to work? Pretend that we don't have the lecture exercise just in front of us, right? So whenever we're kind of swapping values, you remember you always want to either transfer that value you want to swap to a temporary variable or to its new place before deleting it. And so all we need to do to add in a new value into this dictionary is use square brackets. And I know that seems kind of weird. It's similar to how we would do for a list. You put in inside the square brackets, unlike the list, it's not an index. It's the new key that you wanted to add. Now I have to remember how to spell. And then you give it a value just using that assignment operator that we've seen before. And in this case, we want it to be the value that's currently associated with Friday. So we'll just plop in that by indexing the dictionary on the Friday key. So Friday, like so. So if I was going to print this out here, let's print, and not do a capital, print, schedule, and then we'll print it again and we'll see if Wednesday got correctly added. Schedule. So if I run that, you'll see here, my very first line is my initial dictionary that I made. So there's no Wednesday in there. And then my second line has Wednesday added here after Friday. You'll notice that the order of this might seem strange, and it doesn't necessarily match the order that we put it in the code. So you'll see we have Monday, Tuesday, Thursday, Friday initially, but when we print it out, it's printing out Monday, Thursday, Friday, Tuesday. Chaos. And that's just because dictionaries don't guarantee the order of the keys. They just guarantee that the keys will be mapped to the values. If you need something that guarantees the order, you'll need to use a list. And you can use lists of dictionaries and dictionaries with lists in them and all sorts of things, but you'll dive a little bit more into that in the later computer science classes. But it's very, very important to remember that just because we specified it like this in the computer, that doesn't mean that's how the computer is going to store it in memory for a dictionary. They don't guarantee the order to be the same, but they do guarantee that all the key value pairs that you have will match up and be present in that dictionary. And then you'll even see when we added Wednesday, it kind of got added into the middle of the list there. So now at the end here, the very last thing we want to do is remove Friday. In the solution, it shows you how to use the DEL keyword to do that. And I believe in the textbook, we talk about the pop keyword to do that. So schedule.pop, and then we'll pass in that key And we'll spell it correctly, Friday, and then let's print it to make sure that that worked properly. And try it. And you'll see here now we have our first one, our first dictionary being printed, our second one that has all of them, and then our third one that has Friday removed. So, woohoo! Our first little thing with dictionaries all done. And I'll bring this over just to talk about one more thing before we move on to the next one. Just like with lists, we can access any key and value pair in the dictionary by using those square brackets. So if we wanted to add one to, say, I don't know, Monday, we can just do that using the square brackets, the key, and then you can do the same kind of editing that we've done before, where we're saying take the current value of what's stored with Monday and add one to it. So very similar to what we've done before, and then that would change that. So we can run this again and we'll see it being changed, or will we, because is it mad at me about something? This is why we don't do examples on the fly. Make sure I spelt everything correctly. Schedule. I didn't spell everything correctly. That's usually my number one error that I have, is I've made a typo somewhere. There we go. And so now you'll see that Monday has 9 associated with it in the last 2 calls because we updated it here. So you can do that same thing that we've seen with lists before with dictionaries, by accessing it through the keys to modify the values. Okay? All right. Get rid of all my gray boxes. Okay, so let's move on here to exercise 2. We're going to suppose we have a dictionary called class list, where the keys are the name of a student and the values are the student's final grade. We want to write some processing code that increases the final grade by 2 for each student. I just totally spoiled this exercise. So I showed you effectively how we can modify things here with Monday. In order to do this for a whole dictionary or loop through all of the keys, all we're going to need to do is add in a loop outside of that. So first I'm going to just make a class list dictionary just so that we can make sure our code is working. So in this class list, we will use my dog's names and we will give them grades. Ryder gets 105%, of course, because he is the best dog. Vader, he can get a 95%. He's almost as good as Ryder, but not quite. And Rambo will get a solid 60% because he has a lot of learning to do. He's just a little pup. So that's my class list with my grades associated with it. Now we want to loop through and add, what was it? Increase it by 2 for every student in my class. So one way we can do this is through a for loop. So for, we'll just call it student in class list. Python knows that this is a dictionary and it knows how to go through and grab out a key for every element of that dictionary. Unlike a list, it's not going to be returning the value, it's returning the key. So if I was just to do this and then I said print student, I would only expect it to print out the keys that I have in my dictionary. So the dog names in this case, or my student names. So if I were to run this, you'll see I only get Vader, Ryder, and Rambo. And again, you see that they're not in that same order that I typed them out in, but that's because dictionaries don't guarantee order. If we wanted to get the values associated with that, we would have to use indexing. So class list, and then index it on that student key that was returned to get the values. So if we run that, you see now we get the values associated with it. So now, if we wanted to add 2 to everything, all we need to do, is take that dictionary called class list, index it by the key that we're given from the for loop, and then update that value just like we did in the last example there. So class list student, take the current value of class list student and add 2 to it. And then after my for loop, I'm just going to print out my class list to make sure that all of those things were properly modified. And if I run that, we'll see that Vader now has a grade of 97, Ryder has a fabulous grade of 107, and Rambo has a grade of 62. So that's how you deal with for loops in dictionaries. For exercise 3, we're going to have a dictionary called poll that's going to represent employee feedback data. So the keys will be the employee usernames, and the value will either be computers, seating, or support. So one of those three. We want to write a function called poll results, which takes that dictionary parameter poll and returns a new dictionary whose keys are computer, seating, and support, and values are the number of employees who requested that improvement. We'll only create keys in the new dictionary if there's at least one employee that requested it. So I'm going to bring this back over here. I'm going to modify my class list to now be called employee list. And we're going to edit the values of that. We can leave their names and then we'll say that those are their usernames. But we'll edit those values to either be computer support or seating. I think Ryder's biggest concern would be seating, of course. He would like that improved. As would Vader. Both of them are a little bit lazy and enjoy a good spot to sit. Rambo, on the other hand, I think he would care the most about computers. He's the one who's always trying to come into my office while I'm doing these videos and help me teach computer science, even though he doesn't maybe know anything about it. So I'm just going to make that employee list so that we can use it later to test our function. Our function that we're supposed to make is called poll results. So we'll just use our def keyword, which we've seen before, poll results. And we're going to be passing in a dictionary that's going to represent that employee list with their feedback. So I'm just going to call that poll. You can call it whatever you wanted to call it. Again, it's just a name that's going to be associated with a value similar to a variable, right? And then what we need to do here is we need to go through that employee list, make a new dictionary that's going to keep track of how many times each of the different feedback was requested, and then return that dictionary at the end. So when we're doing things like that, you got to kind of think back to what we did with lists and how when we were gathering information and kind of collating it into a new source, we often wanted to start off with an empty list that we could add to. This is the exact same situation, but we don't want a list, we want an empty dictionary. So I'm just going to call that empty dictionary results. And to make an empty dictionary, you just do curly braces with nothing in between it. After you do that, what we can do is loop through all of the keys that are passed in the poll dictionary, figure out which of the different, feedbacks they were requesting. That's not the right word. Anyways. And then add that into the results. So we're going to do a for loop for, let's call it feedback in poll. We're going to add to results. What we need to figure out is the feedback from the person or the employee's name that we have. So I'm going to break this up into a couple of steps. You could combine this all into a single step, but I think if we break it up into a couple, it makes just a little bit more sense. So we have our feedback in our poll. Feedback, maybe this is a bad name for it. Maybe I should call it employee name. Employee name. This is why I usually don't call them long things because I have a hard time spelling. So this is going to give our employee name. And we need to check to see if that feedback that they're requesting is already in our dictionary. If it's not in our dictionary, we're going to add it. If it is in our dictionary, we're going to increase the value by 1. We don't want to go through and just add all 3 of those different options into the results and give them a starting value of 0, because the question specifically asked us to say if there was no feedback in a certain area, don't include it in the final dictionary. So we need to be a little bit more creative with how we gather and collate those results. So first we're going to check to see if the feedback is already in results. So if pull employee name, because this is going to be our key, remember? So this would be like rider, for instance, and then we would be getting what their feedback was. So if that is in our results, oh, here, actually I want it to be, do I want it to be in? Sure, it can be in. And we're just using that in keyword similar to how we would use it in lists. That's going to go through and check to see if that already exists as a key in our results dictionary. So if it's already in there, then what we're going to do is go to results, and then we're going to pass in this whole section here as the new key in results, because this is going to give us a seating or a computer or support, which is going to be the keys of our new dictionary. So if that's the case, then we just say, okay, take the current value of that because it's already in there and add 1 to it. Else, it's not in our dictionary and we want to add it. So then we would add in, again, to our results dictionary, the key that would be either seating or computers or support, and we're going to give it an initial value of 1 to start off with. Now this can be kind of confusing. It might be easier if you want to think about it like add in a feedback variable, then put in that value that you would get from the dictionary that you pass in, given the key that you have. You can separate it out in all sorts of different ways to help it make sense. What I want to do at this point is test to see if this works. And I just realized it's not going to work as I expect because I'm not actually returning my results. So I need to add in that before I get too far ahead of myself here. So let's add in my return for my results dictionary. Okay. So I have my employee list. I'm going to just print my call to pull results. And I'm going to pass it in my employee list that I made. And now I would expect this to only have seating and computers as keys. Seating should have a value of 2. Computers should have a value of 1. And we shouldn't see anything related to support. Now if I run this, we got computers 1, seating 1, and seating 1. And you know what that is? Because your prof is a typo queen. Let me fix that. And then we'll rerun it. There we go. Computers 1, seating 2. That's what we want to see. And I will move on from this question before I get any more embarrassment. There we go. So here's another example that you could pass in. You can try in all sorts of different things if you're interested in that. All right, so we're going to move on to an example of how we can use dictionaries. And so one of the very common places that we would use dictionaries in computer science is for ciphers. And so ciphers are where we take a string or a message of some sort and either encode it into kind of like a jumble of characters or decode a jumble of characters into the original message. So there's always going to be those two ways that you can go. So you'll have your message, and you can encode it into some sort of secret, we'll call it. Or you can take that secret and you can decode it into the message. And dictionaries are a great way for us to computationally represent that because we can use the key value pairs to represent either encoding. So where we would say, okay, if we see a character K, we actually want to represent that as a different character, whatever we choose, or we can use it for decoding. So there's kind of usually 2 dictionaries involved, one for the encoding and one for the decoding. We're going to do an example where we build up both of those different ones and then show how we can use it on different strings. So the example here is this message here, which is already kind of represented as a secret message. So SVJJT doesn't mean anything in and of itself, but when we combine it with a cipher that can be used for decoding, so what this would be called a decoding cipher, it would say, okay, if we see an S character, let's replace that with an H, which we would do down here. And then we see a V character, let's replace that with an E, and so on and so on. And so when that decoding cipher is used with that secret message, the decoded message we would get at the end would be hello. So what we'll do is we're going to write a function called load cipher, and the parameter for that is going to be called fname, which is a file name that will load an encoding cipher from a file into a dictionary and then return it. Each line in the file is going to hold the original character followed by the encoding character. And then here's some example data with our expected return to be this right here. I'm just going to quickly download that in the input file so that we can use that instead of having to build up our own. I forgot to do that before we started, and I apologize, but it will take me not very long to download it here. I should have said, place your bets in the comments how long it will take me to download this. I'm not that good of a YouTuber, can you tell? And then I'm just extracting. Yes, sure, extract it there. Lovely. And here we go. So here is an example of what the cipher would look like. So you'll see we have, I think, every character represented, and then what we would be mapping it to. So this is, I believe, the encoding. So we would take a message and then encode it into something else. I will just open up the example that's in the same, here we go, the same folder so that I don't have to worry about putting that all in the same place. There. So load cipher is our function, one parameter called fname, and then we're going to use it to build up that dictionary that will return. I think there might be another page here. No. Okay. We'll get started on that then. So same as we always do with functions, def, and I've already forgot the name, load cipher, and I've already spelt it wrong. And then fname is our parameter, which would represent our input file. We know we're going to have to return a dictionary. So again, we'll probably want to have an empty dictionary that we're starting out with so that we can add things to it. Since we're working from a file, we know we're going to have to open that file, go through it line by line, and as we're going through it line by line, we will be putting that data into our dictionary. So as a reminder, line by line would mean we have our first value here, or our key on the one side, separated by a comma, and then we have our value. So we're probably going to want to do some splitting with that split command, some rstrip to get rid of those new lines so that they're not included, so on and so on. So to open a file, just as a reminder, we always start with a variable, which is going to store that open file for us. As I mentioned in this class, we often use the variable name f to represent that. That's just a convention we've gotten used to, but you can use a different variable name if you would like. We use that open function. We pass in the file name, which is a string. But since we know we're passing in the file name as a string to this function, we just have to pass in the parameter name that we're providing to the function. So fname in this case. And then, of course, telling the computer, hey, mentally prepare yourself. We're going to be reading from that file. And we use our for loop to go through each line in our file and get some data from it. So first we're going to strip off the new lines using rstrip. You could put the new line character in here. You don't have to though if you don't want to. Either or will work. And then we're also going to split up the data by the call or by the comma so that we can get each of the different pairs of data associated with that line in a list that we can index and then use to build up our dictionary. Now we need to build the dictionary. So we already have our empty dictionary that we defined outside of our for loop. We're going to use that inside of our for loop. We're going to spell it correctly so we don't make the computer cry. And then remember, our very first element in data is our key, and the second element in data would be our value. So we would say data 0 is our key, and then we assign it a value of data 1. At the very end of our for loop, we will close our file, as to not make the computer cry, of course, and then we will return our cipher. And if we want to test this, we just have to go outside of our function, and we can build up a function call that's going to call the function with the file name we want, and then return the cipher at the end. Since it's returning the cipher, I'm just going to have it print to console so I can make sure that it looks similar to what the file we passed in was. I'm going to make this a bit bigger so I don't have to keep scrolling. We pass in the function name, so load cipher. And then as a parameter to that function, we will do the file name that we have stored in the exact same folder where this code is. And we've just called it cipher.txt for this exercise, so cipher.txt. And then everything else should be handled so far by this function. So we hit run. Woo, and you can see, look at all of those key value pairs. Holy moly, there is a ton of them. And that looks very similar to what we had in this text file here. So if we even jump down to Q, we can make sure that it should have a value of R associated with it, and it does, which is great. I'll move this over and go to the next one. We're now going to write another function called invert cipher, which takes an encoding cipher like we just made and returns a decoding cipher. So that would take like a secret message and then turn it into a message that would make sense. So effectively flipping the keys and the values of what we just made. So if we're going to do that, I'm going to put it in this exact same file so that we can test it using the same things. This function is supposed to be called invert cipher, so def invert. Typing is hard today. That hasn't changed over the course of this term. And then we pass it in, and I put chipper instead of cipher. Cool. And we pass it in a cipher. So that would be a dictionary. It's not called chipper. It's called cipher that we made similar to what would be returned by that function we just defined. So again, because we're expected to return a new dictionary, that's going to be our decoding cipher. We're going to have our empty dictionary to start from. So again, just curly braces with nothing in between. And then we want to go through the cipher that we passed in and just flip our values and our keys. So we'll use a for loop for that. So for every key, can't use key because you see what it did there? It did some nice highlighting for me to remind me key is a very special word in processing, and if you use that, I'm going to try to do something that you don't want me to do. So thank you, Mr. Computer. We'll just call it K then instead in cipher. It's not chipper. Oh my goodness. And then all we're going to do is for our decoding cipher, the value is going to be the key will be the current value that we would get from the cipher we passed in. And then the value would just be the key. So that's the easy part. The other part is where we have to do some mental figuring here, and we would say cipher, which is our encoding cipher, and the value at K would then be the key that we would associate in the decoding cipher. That will go through for the whole cipher for us, and we can just return our decoding cipher. And what I'm going to do now is wrap my invert cipher around my load cipher, which is making my dictionary. Actually, I'll split it up so that it makes a little bit more sense here. So my load cipher, remember, is going to make our encoding cipher. Then we're going to have our decoding cipher get created by invert cipher, passing it in encoding. And I can just print out the decoding to make sure that it is flipped based on what we know is in our text file. And we'll just do a couple of spot checks on that just to make sure that in our guts we know this is running how we want it to. So let's try that. So here everything looks like it ran. Remember before our Q used to point to an R. Now it points to D, which is okay, but we want to make sure that our R is pointing to a Q, and in fact it is, and it's the one right after. So that's great. It's working well. That's exactly what we want to see. Oops. So now for exercise 6, we're going to suppose that we receive a secret message that we want to decode. We're going to write a processing function called decode, which takes an encoded message as a string and a decoding cipher, and it's going to return our decoded message. Characters unknown would just remain the same no matter what. So bring this over here. We're going to add in another function for us. This one is called decode. I was like, oh, I don't remember what it's supposed to be called. That would be because I forgot to highlight it. Get rid of my gray boxes here. And whoopsie. Def decode, passing it in 2 different parameters, one called encoded message and then one for our decoding cipher. So, oh, I already forgot what the first one, encoded message. And then I'm just going to put decoding cipher just so that I remember which one I'm on. So as I'm explaining things, I don't forget. So we have our encoded message. At the very end of this, we want to return a decoded message. So that's probably going to be a very similar pattern to what we were building up here. So our decoded message, we're going to want to start it off with an empty string that then we can add to as we go through every loop or every character in our encoded message, decode it, and then add it into our string. Because remember, strings have a lot of the same methods that we can use on like lists and different things like that, because they really are a collection of characters. I'm just going to add my return statement so I don't forget here. So decoded message. And then I'm going to build up my for loop here that's actually going to do the decoding. So what we want to do is loop through every character in encoded message. So for character in encoded. I always have to check to make sure I'm not using a special keyword. So for that, if the character is in our decoding cipher. I want to say is in, but it's just in. Because remember, we want to check to make sure it's in there. If it wasn't in there, we would just add in the letter that it was in the encoded message. So if it is in the decoding cipher, we're going to make it into the new word that it has. For strings, how we would do that is we just say, okay, take whatever the current value of decoded message is and add something new to it. So similar to what we would do for like adding an integer, adding 1 to some other variable. You say, I want to assign a new value to this variable that we've been working on. We're going to take the current value of that variable, even though I know it's a string. And because it's a string, we can still use the plus sign to add to it or concatenate to it. And in this case, we're going to take our decoding cipher and we're going to index it by the character. And I've spelled this wrong. I'm already seeing all my typos. Oh my goodness gracious. So we're going to index at the character there. Otherwise, if it's not in our cipher, then we just add to our decoded message the current value of the character. So decoded message plus character. Okay, and that should be all we need. So now if we want to try this, all we need to do is call in our decode with an example. What should we use as an example? I didn't pre-plan this, so I'm not going to have any good examples here. Ah, so LOLOL should be ha 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 exclamation point. So let's try that one. Decode LOLOL exclamation point and pass in our decoding cipher. And then let's run it. It might not, I might have missed the O or something. This one says MBMBM. Let's just double check what we have here in our text file for a cipher. So if we bring this over here, oops, our L at the very, oh, sorry, we'd have to flip it. So we're going to go from the second column here, because this would be when we're decoding it, not encoding it. L would go to M, which it did, and O would go to V, which it did, and our exclamation character stayed the same. Poor example. Jeez Louise. I'm sorry about that. But you could try it with this cipher if you wanted, where you built up a different one here and encoded a message and then see if you got the right output. Okay. This exercise 7 here is asking if the following dictionary is an example of a mapping, which is very similar to what we saw before in the ciphers, where we would take a vowel or take a key and map it to a new value or a record. And in this case, we would consider this to be a record because it has key value pairs that are all represented or related to a single data point. And in this case, that data point would be a song. So this song is containing key value pairs for the artist, the title, and the length. You could have collections of multiple songs that would then go into like a list that could represent an album. But because they're all related to that single song, we would explain, or that would be related to a record. Okay. As a way to test all your knowledge on dictionaries, what I want you to do is exercise 8 on your own. You can check the solution in the PDF that's posted, but this is going to redo that planet simulation that we did in chapter 14, except instead of storing planet information in lists, we're going to use lists of records. So lists of dictionaries that contain key value pairs where those key value pairs are associated to information for a specific planet, okay? So all of the exercise slides here go through everything, all the different steps you should take. So work through them one by one. Use it to test your knowledge of dictionaries. Do we understand how to use them? You feel confident in them. If there was a question on the final exam, you could handle that. You'd feel like you were able to tackle that. If you have any troubles, come to Help Hours. And I'll end this video with a final thank you to everybody for hanging out with me for the last 6 weeks. It's been a whirlwind, I'm sure. The 6-week summer courses for computer science are always really jam-packed. But I do also want to remind you all of how far you've come. So 6 weeks ago, many of you had never written a program before. You didn't know what a variable was. And now look at you. You can write programs. You can use variables, lists, loops, write functions. You're really well on your way to becoming like a full-fledged computer scientist. And you should be really, really proud of everything that you were able to accomplish. So make sure to give yourself some credit and some pats on the back because you deserve it. If you're interested in continuing with computer science at the University of Saskatchewan, your next step would be to take CMPT 141. The first little bit of CMPT 141 will review every single thing that we did in this course, but just at a much faster pace. And then you'll be going on from dictionaries into the next topics that you'll start covering. And then after that, you'd be taking CMPT 145 in semester 2 and so on and so on. So congrats again for everything you've accomplished. I wish every single one of you all of the success in the world. And make sure to stay in touch on LinkedIn or whatever, because even once the class ends, I am still here for you. If you need anything, you can reach out and I will monitor my emails, monitor my LinkedIn messages, etc., etc. All right. Bye, all.